it's your friendly neighborhood physics teacher here, and we're going to talk about what happens to the energy as a ball drops, hits the table, and comes back up. Now, in your lab, you could have used any of these balls. You could even use the big one. It just takes up the whole entire screen. And they're going to react the same way. So you drop, it goes. So they go, and it falls. Goes, and it falls. Goes. It's just lab. So a couple of things hopefully you realize is that's why I kind of held my hand there. None of them reached the height that I dropped it at. Now the reason is because there's energy being lost. Now, a lot of people are saying they didn't understand why, because I said there's elastic in here also. The reason is because all of your balls are squishy in some form or fashion. Now you're going, but the golf ball is not squishy. You are correct, but there's actually rubber bands inside, and it does squish a little bit, just not enough to be noticeable. So all of these balls do have elastic. Now, another thing that we did is we took a big one. Let's see if I can do it out here real quick. So we took the big ball and we put a small ball on top of it, and we dropped it. So what happened there? The small ball went flying. Let me do that again. So your small ball went flying. And we need to talk about, why. And we'll do that. We'll do that today also. So I'm going to go ahead and disappear so we can write and see what's going on. The first thing we're going to talk about is just a basic ball going fall. So we're going to start with a ball at some height to the floor, or to the table in this case. So here, hopefully you know that you have gravitational energy, specifically max gravitational. As it starts to fall, that gravitational energy is getting turned into kinetic. So again, it's an even transfer. That gravitational kinetic is getting turned into, or that gravitational is getting turned into kinetic. Right before it hits the ground, you're going to have max kinetic. Now, from here to here is considered a closed system. Those are all going to be equal to each other. So if we're looking at our equation, we have our gravitational max. That is going to end up equaling our gravitational plus kinetic, which equals our kinetic max. So those are all equal. It's an even transfer, starting out with gravitational, getting it converted into kinetic. Now, as soon as that ball hits the ground, one, you hear something, right? I mean, you definitely hear it with the golf ball. You hear that sound. And what that is, that's a loss of energy. So here you have this, max kinetic energy, but you're losing energy due to friction. And that's the sound, that's the a little bit of thermal energy, so you're losing that energy. But since it's squishing, since the ball squishes, you're also gaining elastic potential. But you're not gaining enough energy to overcome that loss of friction. So that's why it doesn't get to the same height. So that would be all greater than, there we go, our max kinetic minus work plus elastic. So you're gaining that elastic energy, but it's not enough to overcompensate by how much energy you're losing due to work. Now, all of that is going to end up equaling, again, you're just kind of repeating. You're going to have some type of kinetic, which equals some, that kinetic getting turned into gravitational, which would equal gravitational. But if you notice, none of those are max, because there's no way it could ever be max, because we've lost some of that due to friction. And you could keep going, and then you'll fall back down, go to kinetic, but then you lose even more energy. That's why it starts out high, it bounces, goes a little bit lower, bounces, goes a little bit lower. Every time it hits, it's losing that energy. So that's kind of like your equation for bouncing balls. Again, on your, so this would be the equation, but in your paragraph, you're trying to talk about why this is it. What work, what's causing that loss of energy and stuff like that due to work. Now, for the two balls that are, so we had the big blue ball, and then we had a little red ball on top. And we held them at some height. So we held them at some height. So again, they both have gravitational and be max gravitational. As they fall, that gravitation is getting converted into kinetic. Right before they hit the ground, they're going to hit their max max kinetic energy. Now the big difference is when they hit the ground. The big difference is when they hit the ground. That blue ball is going to squish. That red ball is going to squish a little bit. So you're still going to be left with some kinetic energy. You're still going to have that max kinetic energy. You are going to lose some energy due to friction, but the amount of energy you're gaining, because you're gaining elastic potential from the blue ball and you're gaining elastic potential from the red ball. You're gaining both elastic from both balls. And then when it starts going back up, that's when it kind of starts to separate. You have your kinetic energy of the red ball. Kinetic energy of the red ball is going to be way bigger than the kinetic energy. Red ball is going to be way bigger than the kinetic energy of the blue ball. To be greater than the blue ball. Because one, the blue ball has more mass than the red ball. And some of that energy of the red ball or the blue ball is getting converted into the red ball. So that's why it's able to shoot up way more than it did. So it's an extra gain versus before it was almost an extra loss. So that's kind of explaining those two scenarios. If you have any questions, please ask. Remember, you're loved and appreciated. Have a wonderful day. Bye.